Hello everyone, and welcome to another video in my channel. In this video, I have a very interesting system of equation to solve. I have x plus 1 over y is equal to y minus 1 over x is equal to 1. I'm required to find the value of xy in bracket to power 9 minus 1 over xy in bracket to power 9. What am I going to do to solve this problem? But before I proceed, I would like you to pause this video and try this question. Then come back in the comment section. I would like you to comment on which method that you use in solving this problem. I would also like you to like this video if you find it interesting. Subscribe to my channel if you haven't done so, and also share this video. Now, enough of the commercials. Let us now solve the problem. To solve this problem, I'm going to split this system of equation into two systems of equation. That is x plus 1 over y is equal to 1, that is equation 1, and y minus 1 over x is equal to 1, which is equation 2. Then I will multiply 1 and 2. That is x plus 1 over y times y minus 1 over x is equal to 1 times 1. Now let us open the bracket. X times y is xy. X times minus 1 over x is minus 1. Then 1 over y times y will give us 1. And then 1 over y times minus 1 over x is minus 1 over xy. And 1 times 1 is 1. This and this will cancel out. So we have xy minus 1 over xy is equal to 1. At this point, I can multiply out and then get a quadratic equation and then solve it. However, this looks like the golden ratio. If I have the golden ratio, which is represented by phi, and then phi is equal to a over b, where a is greater than b, I can rewrite it as a plus b over a. This is another way that I can express the golden ratio. Now I can split this fraction into two fractions, which is a over a plus b over a. So phi is equal to a over a is 1 plus, now this is a reciprocal of a over b, which is phi. So I'll write 1 over phi here. If I bring this term to this left hand side, it becomes phi minus 1 over phi is equal to 1. Now this expression and this expression are exactly the same. It then means that xy is equal to phi. And so xy to power 9 minus 1 over xy to power 9 is equal to phi to power 9 minus 1 over phi to power 9. But we know that phi has a numerical value, which is 1 plus root 5 all over 2. It is actually an irrational number. But I can find 1 over phi. That becomes 1 over 1 plus root 5 over 2, which is 2 over 1 plus root 5. Now, if I rationalize the denominator, I'll get 1 minus root 5 all over 1 minus root 5. Now, 1 over phi is equal to, if I multiply by 2, I have 2 minus 2 root 5 over, this is difference of 2 squared, so we'll have 1 minus 5. So I have 2 brackets 1 minus root 5 over minus 4, where this and this will cancel out to give us minus 2. Now, 1 over phi is equal to 1 minus root 5 all over 2. I can put the brackets here and then multiply by this minus. Now, if I multiply this 1 over phi by minus, then this minus will cancel out. So I have 1 minus root 5 all over 2. Now, going back to this expression, if I multiply through by phi, I'm going to get a quadratic equation in phi. So phi squared minus phi minus 1 is equal to 0. If I solve this equation, I'm going to get this as one of the roots and this as the other root. So it then means that 1 plus root 5 over 2 is one of the roots, and the negative reciprocal of phi is the other root. Then all this shows that I can rewrite this expression, which is phi minus 1 over phi, as phi minus plus minus 1 over phi. And so 5 squared minus 1 over 5 squared is equal to raised to power 9, please. Raised to power 9 is equal to 5 to power 9 plus minus 1 over 5 to power 9. Now we are tempted to just substitute 1 plus root 5 over 2 where we have our phi here. Believe me that this is going to be very lengthy and time consuming. However, life is too short for such lengthy and time consuming exercise. I'm going to introduce a shorter method of solving this problem, and that method involves the Binet formula. So what do we know about the Binet formula? We have it as f subscript n is equal to 1 plus root 5 over 2 all to power n minus 1 minus root 5 over 2 all to power n all over root 5. We know that this is phi and this is negative reciprocal of phi. So fn is equal to phi to power n minus 1 over phi to power n all over root 5, which we can express as, if I multiply by root 5 out, I have root 5 here times root 5 is equal to phi to power n minus 1 over phi to power n. So what is this number f sub n? F sub n is a term in the Fibonacci sequence. Now, what do we know about the Fibonacci sequence? I have 1, 1, 2, 3, 5, 8. 5 plus 8 is 13. Now, 8 plus 13 is 21. 13 plus 21 is 34. And 21 plus 34 is 55, and it continues indefinitely. So Fn is a term in this sequence. Now, since we have n is equal to 9, n is equal to 9 according to this expression we are asked to find. So it then means that F9 is the term that we are looking for. And if we count these terms, 1, 2, 3, 4, 5, 6, 7, 8, 9, F9 is 34. Therefore, I'll put 34 where I have my f sub n. So it becomes 34 times root 5 is equal to 5 to power 9 minus 1 over 5 to power 9. If I multiply this out, I'll get 76. So 5 to power 9 minus 1 over 5 to power 9 is equal to 76. And that solves the problem. You see, it is easier than substituting 1 plus root 5 over 2 in this expression and then finding the value of this expression by multiplying the brackets out. It will be time consuming.